Hello everyone, hope everyone is doing well. So this is the post analysis of the Geeks for Geeks weekly contest which happened recently. I hope you were able to solve most of the questions out of 4. So let's start the first question. Let's see what it is saying. First question is minimum cost to buy the candies. Let's read the question. Given a shop with n candies, each with the price listed in an array of prices, where prices of I represent the cost of ith candy. The shop offers a special discount, which are mentioned below. Here are the some important points given the problem. If you purchase X candies, you can get up to X additional candies for free. However, the free candies must have prices less than or equal to highest priced candy among the X candies you bought. Each candy can be bought only once. Our task is to determine the minimum amount of money required to purchase all the candies in the shop. So what these three important points are saying that if we purchase some X candies, so we can get additional X candies for free. For example, let's say you bought candies with price 3, so you can get additional 3 candies for free. Let's say you bought 10 candies, so you can get additional 10 candies for free. And that the additional candies which we are purchasing, that price should be equal to or less than or equal to the highest price candy we bought. Okay, and each candy can be bought only once. Our task is to determine the minimum amount of money to purchase all the candies in the shop. So main thing is that we have to purchase all the candies. In this problem, if I purchase the candy with price 3, so I can purchase 2 and 2. Why? Because the 3 is the highest amount of candy I have. Okay, so let's see this example. 2 3 2. We are given an array 2 3 and 2. Okay, 0 based indexing 0 1 and 2. If I purchase the candy 3 and 2, if I purchase 2 and 3 candies, I can get one additional candy for free. Okay, so my total price will be 5 in this case. Got this? So, and one thing is that are the additional candies which we are purchasing, that should be less than or equal to the highest bought candy we get. Let's say in this example we have 2 additional candy, so that is less than or equal to 3. One example, let's take this only again, 2 3 and 2. What if I bought only 2 at the first thing? What if I bought only 2 at the first time? So my initial cost is 2. Okay, now next time, can I buy 3? No, I cannot buy 3 next time because it is not less than equals to 2. I can only buy 2, so it is free for me. Okay, now again I have to purchase 3 again, 5, and then next time I have to again buy 2, which is 7. So total price would have been 7 for me. So one thing we are sure that we want to purchase the maximum price candy at the first. So how can we purchase the maximum price candy at the first, at the initially? If we sort the array, if I sort the array, if I sort the array, I can I can purchase my maximum candy, maximum priced candy, priced candy. How? If I sort this array with 2, 2 and 3, I am sure that 3 is the maximum price candy. Yes. So initially my cost will be 3, sorry. Initially my cost will be 3. Now I can purchase these 2 candies, but not for free. If I purchase this 2 candy, which will make my total cost to 5, I can get this candy for free. Got this? So let's say another example, it will be more clear. Let's say I have a large example, 1 1 1 10 and 1 1 1 1. Okay, let's say this is our example. Now if I purchase this candy, I can only purchase this candy. Okay, if I purchase this candy, I can only get this candy. If I purchase this candy, I can get one extra candy. Similarly, if I sum up all, it will be very large value. So, but I want the minimum amount of cost which I can purchase all the candies. Okay, so one thing is that if I purchase this candy with price 10, I can get 10 candies at a one time with free value. Okay, so that will not add up to my cost. Got it? So let's first try to sort the array. Okay, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 and 17. If I purchase this last candy at a single point of time, so now I got this candy at a single point of time, my total cost is 10. Now see here in this array, now this part of array is left. What if I purchase half of the candies? What if I purchase half of the candies? My If I purchase half of the candies, my other part will be free for me. Okay, so I am neglecting this part for free and I am making it more optimal to purchase it. Got this? I hope this made sense to everyone. I hope this thing makes sense to you, right? So let's count this. If I make 10 here, okay, 10 was the initial cost. Now to make these candies for free, I will purchase these many candies. Okay, so my total cost will be 1, 2, 3, 4, 5, 6, 7, 8. So my total cost will be 18, and these candies will be free for me. Okay, so how can we do that? My algorithm will run like algorithm. Firstly, sort the array, then initialize your total cost with 0. Initialize your total cost with 0. Now add add the last price candy directly to your cost, which is my highest price candy, so that all other candies are less than equal to my highest price candy. Okay, now in remaining array, purchase only half of candies, so that other half becomes free for me. Other half becomes free. As we discussed in the example, that if I purchase this part of the candy, I will be able to purchase this part of the candies for free. Okay, so this is how our code will run. Got it? So this is our code, in which first we have initialize the price of the candy, then we have sort the array in descending order, ascending order. Now we have added the last highest price candy in our cost. At last, when I will only add half of my candies, okay, to my answer. At last I'll return my cost. This is the same thing which I returned in the algorithm. I hope this problem made sense to you. Okay, the sorting was the only logic in this code, logic in this problem. Now let's move to the next problem, the multiplication game. This is a very interesting problem. This is an observation based pattern in the problem. Okay, now let's see what the problem says. Given an array consisting of elements ones and minus 1 only, along with an integer x, initially set to 1. X is set to 1. Two players, Alice and Bob, take turns one by one selecting a number from array. then multiplying it with x, and then removing that number from array. So how our problem will run like, firstly, Alice will make the first move, followed by Bob, and then continue taking turns. That first Alice will take, followed by Bob. Each player will make exactly k moves. So that total number of moves in the game is 2k. Alice will have, sorry. So Alice will have Alice will have k moves. Bob will have k moves. And we want both the players to move to take exactly k moves. So total moves will be 2k. Okay. Now Alice's goal is to ensure that final value of x remains 1, and Bob's goal is to make the final value of x to -1. Return true if Alice wins the game, otherwise return false if both of them plays the game optimally. So what the question is saying, that if final value is 1, means it is positive, then Alice wins the game and return true. Otherwise, if the final value is negative, means Bob has won the game. And we have to return false. I hope you have understood the problem. Okay. So Bob will try to make the value as negative as possible, and Alice will try to make the value as positive as possible. We want to return a boolean value, either true or false. Okay. So let's see the example. 1 1 minus 1 minus 1 1 1 1 minus 1 1 minus 1 minus 1 1 and minus 1, and our k is 2, I guess. K given is 2. Yes. So see in this. Okay. So in this, our answer will be false. Why answer will be false? Because we have two positives and two negatives. Okay, sorry, we have three negatives in this. Got it? Now Alice will make these two moves and will make the answer as positive, but three negatives will give you a negative answer. So total answer will be negative in this case. Bob will make all these negatives, minus 1 minus 1 minus 1, and your answer will be negative. So total answer will be false. Okay, so in this problem we'll move case by case. So let's say we have case 1. We have case 1. Okay, in which when your minimum priority element is positive. That means your positive is less than negative. One thing is that the first thing we'll do, count frequency of positive numbers and negative numbers. So see, when minimum priority element is positive, that means when your positive number of positive is less than negative. Okay, and your positive is even, that means your frequency of positive numbers is even, and your positive is less than equals to k. For example, let's say you have 4 positive, you have 13 negatives. Negative is 13 and your k is 4. So in this, your 4, you have 4 positives, that will make you give the answer as positive only. You will not get answer as negative in that case. Similarly, for -1, 13 negatives will not be able to occupy all the k, all the negative values. We will be left with some negative values, right? Let's say 4 positive will exhaust all the positive values. Alice will exhaust all the positives. Now, negative we have 13. Even number of We will use even number of negatives. Why? Because 13 and we want 4. We have 4 terms, and 4 terms will have even number of negatives. So even term of negatives. What if you multiply -1 into -1 into -1 into -1? This is your k terms, right? So it will definitely give you the positive value only. Got it? So it will give you a true value, that Alice will definitely win at last. At last. That means Alice will exhaust all the positives, and Bob will also use even number of negatives, which will give you a positive value. So at last the answer will be positive only. So return true in this case. Let's take another case. Case 2. When your positive is less than your negative, and positive is less than k, less than equals to k, but your positive frequency is odd. Okay, let's say your positive is 3, your negative is 13, and your k is 5. Okay, now Alice will exhaust all these positive values in the answer. Yes or no? Positive will exhaust all these k's, and it will also left with some positive values also, because we can't will not be able to use 3 positive values out of 5. 2 positives will still be remaining. Got this thing? That we will be only able to use 3 positives out of k, and 2 positives will be remaining. Now we'll use now 5 negatives: -1, -1, -1, -1, and -1. Okay, so this will ultimately give us a negative value at the end. Three positives, three positives will give us a positive, but 5 negatives, that is the odd number of negatives, will give us a negative value. So that in this case, Bob will win. Bob will win the case, because ultimately the final answer is giving us a negative value. Another case can be case 3. When your positive is less than negative and your positive is greater than k. Okay, in this case, Alice will not be able to exhaust all the positives. Let's say you have 5 positives and k is 3 only. So still, if you use 3 positives, then also your 2 positives will be still be remaining. Okay, so you will not be able to use all the positive numbers. Okay, so Alice will not be able to use all the positive values. So some this means that some values, some positive values will still be remaining. Will still be remaining. Meanwhile, when Bob will start using the values, that time he will use the negative values out of all. Okay, so since he will use the negative values, so our ultimately answer will be negative only, because Bob will select all the negative numbers, and Alice will not be able to exhaust all the positives. That means the chance of getting a negative value is more. So in this case also, Bob will win the case. Win case. So one thing is that if our positive is even, and then your positive and your k is also greater than positive, In this case, you can return true. Otherwise, you will return false. Similarly, the above cases we discussed just now, same if we apply for negative also, that if our negative is even, negative even, that means we will get a positive value. -1 is occurring 4 times, that means we will get a positive value. If your k is greater than equals to your negative frequency, you will return a true. Otherwise, return false. These are the only two cases based on my observation which will give us a correct answer. Let's see the code as well. Firstly, initialize or positive, initialize or negative with 0. Firstly, count the frequency of positives and negatives. If your array of I is greater than 0, increase your positive count, otherwise increase your negative count. Next, if my positive count of positive is even, then I'll check if my k is greater than equals to positive or not. See, we discussed above that if our k is greater than k is if our k is greater than equals to positive, we'll return true. Okay, then we'll return true. Otherwise, we'll return false. That will not be able to use all the positives. Now, next thing is if our negative is even and k is greater than equals to negative, so we'll return true. Otherwise, we'll return false. This is the thing we discussed above. Please see the video again if you have understood. If you haven't understood, above the 3 cases, if you listen again, you will be able to understand it. Okay. So this is the code of this problem. Please watch it carefully. Okay, mainly these two cases only solve the problem of ours. These two cases only. I hope the problem is clear. Now let's move to the next problem. City shutdown. It is a very interesting problem. In a kingdom of n cities, 0 to n-1 connected by n-1 roads, there is exactly one path between any two cities. The kingdom depends on this network where every city is accessible from every other city. However, the evil mayor decides to shut down one city, causing the roads connected to be severed. Given an array of roads such that roads of I equals to u, v, denoting that there is a road connecting city u to v. The task is to determine the maximum number of pairs of the city that will become disconnected once the mayor shut down just one city. So we have to just remove one city and we have to find that how many cities will be disconnected. Let's say in this case our 0 is connected with 1, 1 is connected with 2, 1 is connected with 3, 1 is connected with 4. Let's draw this in another way. 0, 1, 2, 3 and 4. Currently, every city is accessible from each and every city. From 0 you can go to any city, from 1 you can go to any city, and 2 you can go to any city. Let's see. If I remove 0, how many networks will be disconnected? Only 3. Let's say 3 0 will be disconnected, 1 0 will be disconnected, 2 0 will be disconnected, 4 0 will be, sorry, 4 networks will be disconnected. Okay, it will be similar for case for 4, 2 and 3. Okay, but what if I remove 1? What if we remove 1? If I remove 1, then my 0 4 will be removed, disconnected. My 0 3 will be disconnected. My 0 2 will be disconnected. My 2 3 will be disconnected. My 4 3 will be disconnected. And my 2 4 also will be disconnected. See, if I remove 0, I cannot go from 0 to 4. I cannot go from 0 to 3. I cannot go from 0 to 2. Yes? I cannot go from 2 to 4. Okay, I cannot go from 2 to 3. I cannot go from 3 to 4. Okay, understood? So number of disconnected pairs is, maximum number of disconnected pairs is 6. So I hope this question is clear to you. Let's understand how we can solve this problem. So one basic idea, one key idea to solve this problem is that if when a node is removed, let's say this node is removed, we get some amount of subtrees, right? We get a 0 1 and we get 1 2, 1 3 and 1 4. If I remove this connection, if this connection I remove, so I get subtrees. Okay, and we can also find out what is the maximum number of disconnected pairs, how many, like how many nodes are in each of the subtrees. From that also we can determine the problem. Like say for a node, if we remove that node, tree will split into several subcomponents. Then for each child of the node we can calculate the number of pairs. For each child we can calculate the number of pairs. Using this idea we'll solve the problem. Okay, so we will use a depth first search to solve this problem. How we'll solve? Let's see. We are given this array. Let's make a tree first. Let's make a tree from this given input. From 0 we can go to 1. From 1 we can go to, since it's an undirected tree, from 1 you can go to 0, from 0 you can go to 1. From 1 you can go to 0, you can go to 2, you can go to 3, you can go to 4. From 2 you can go to 1, from 3 you can go to 1, and from 4 you can go to 1. So this is your graph. We have made your graph now. So let's see what are the maximum number of children a single component node have. Okay, so 0 1 2 3 and 4. So we will make a DFS. Let's make a subtrees. Let's make a subtree array. This array will tell us that how many subtree a single element has. Like for each child will iterate separately. For 0 will iterate, for 1 will iterate, and for 2 will also iterate. Okay. So when will come to 1? When initially will come to 1. So make the subtree size. Initially if we have a single node, then what is the size of this tree? Only 1. So initially make the size of this tree as 1. Now when will come to, from 0 will come to 1. Make the, now focus on this 1. Now we will make the subtree size of 1 is 1. Now when will come to 2, we'll make the subtree size of 2 as 1. Now 2 doesn't has any children. So from 2 will go back to 1 and add the size of 2 to our size of parent to our size of child to our parent. This 2 will be added to 1. So make it as 2. Now from 1 when we go to 3. So from 3 make the size of this subtree as a 1. Now when from 3 it has no children, so will not go anywhere, will directly go to 1. So to add 1 also in this. Now from here we go to 4. From 4 add the size of 4 as 1 in the 4. Now from 4 when we come back to 1 again and add this size to your parent, which is 4. Okay, I hope this DFS was clear, that firstly you will subtree of node will be equals to 1. Now you will iterate in the array for child in your graph of node. Check if your subtree of child is not equals to -1, then call the DFS. Call the DFS of child or graph entry, graph and subtree. After coming back, add in your parent subtree of node plus equals to subtree of child, right? So this is how you will get to know that this parent will come to know all about its subtrees. Okay, so now our subtree is completed. So we have subtree as 1 4 1 1 1 0 1 2 3 4. This was our tree 0 1 2 3 4. By seeing in the subtree array only, you can tell that from 0 you can visit only one child, from 1 you can go to 4 nodes, from 2 you can go to 1 nodes, from 3 you can go to 1 node, and from 4 also you can go to 1 node only. I hope this till this point you have understood the problem. Now what we'll do, we'll visit each and every direct child of the parent. We will visit each and every direct child of the parent. Okay, so what we'll do now, firstly visit 0. We'll visit node 0 1 2 and 3 and 4. We'll have a array disconnected array, which will store that if I remove any number of node 0 1 2 3 0 1 2 3 4, any number, any index will tell me that if I remove this 2, then how many pairs I'll disconnected. If I remove this one node, then how many pairs will be disconnected. This will store this answer. Okay, and we'll also store a max node. We'll have a max node as -1, that initially we don't know which node has the maximum number of pairs. At last I should return disconnected of max node. Okay, this will be an answer. Disconnected of max node will return the maximum number of pairs that will be disconnected. Okay, now let me bring this also. Let me bring this down. Okay, now let's first visit the 0th node. What we will do, firstly initialize the pairs with 0. That currently I have 0 pairs and initially my size is 1. Obviously we have size 1, right? A single node is also an element, so initially our size will be 1. Now try to visit, what I said, we will visit the direct child of the parent. So firstly visit to 1. Firstly we'll visit 1. Now what we'll do, we have a formula to calculate the number of pairs. Pairs equals to, like for every element we are gonna add pairs. So pairs plus our total size minus the number of disconnected pairs will be updated using this only. So disconnected pairs will be size into our total n minus visited nodes minus size of child. This will give us pair. Okay, and at last what we'll do, disconnected of current node will be equals to pairs. This will be our operation at each and every point of time. Got it? Okay, now let's start the dry run of this problem. We'll do the dry run now. Focus now. Focus everyone. This is our tree. This is our graph. We have a disconnected pairs. We have an array also, subtree array. 1, 4, 1, 1 and 1. 0, 1, 2, 3, 4. Now, initially our pairs is 0. Will iterate by 0, 1, 2, 3, 4 node wise. Now, currently our pairs are 0. Okay. And visited node. That means we have visited currently the 0th node. So, visited nodes equals to 1. Now we'll go to inside the child of this node. Okay. So, first child is 1. Child equals to 1. So, we'll calculate the pairs. But we can also do one thing, that if our child of if the frequency of this child is greater than our parents, then we can directly calculate the size. Okay, that how many pairs will be disconnected. So total will be n minus subtree size of node. That means 4. One pair will be disconnected if I from 0. If I disconnect this path, so I can get to know that one path will be disconnected if my subtree of child is greater than my subtree of current node. If it is greater, then directly do size equals to n minus subtree of child, which will tell us that how many pairs will be disconnected at that time. Okay. So initial size will be 1. Now we'll calculate pairs now. Calculate the pairs. Pairs equals to initially pairs 0 plus size. What is our size? 1 into n. N is 5 minus visited node is 1 and my size is 1. 0 plus 1 into 5 minus 2, 3. See, so total pairs will be disconnected for 0. For 0 total 3 pairs will be disconnected. Okay. If I remove 0, so total 1 0 2 0 sorry 2 0 3 0 and 4 0. These 3 pairs will be disconnected. So I got 3 here. So I will put 3 at the point of the disconnected, and our max node will be 0 currently. Okay. Next, I will travel for 1. Now 0 don't have any children. So now let's move to 1. So initially pairs is 0. Visited node is 1. And child. Initially child is 0. We'll calculate it again. So subtree of child. Child is 0. Subtree of child is not greater than my node. So I will not do anything. I will directly calculate my pairs. How I calculate my pairs? See, the formula of pairs is pairs plus equals to size into n minus visited nodes minus size. This is a formula to calculate pairs. Got it? Pairs equals to pairs plus. This is our formula to calculate the number of pairs. Initially our pairs are 0, so we'll not do anything. Currently we'll explore the 0th wala thing, 0th wala student, child. So pairs. So initially our size will be 1. Subtree of child. Size is 1. Pairs equals to pairs 0 plus what is the size 1 into n is 5 minus visited node is 1 minus size which is 1. So 1 into 3, 1 into 5 minus 2 is 3. So initially pairs will be 3 only. So disconnected node of pairs will be 0, 1, 2, 3 and 4. Here we'll put 3 here first. Now when will come to 2, again our size will be, so visited nodes will be equals to size plus equals to size. So visited node is now 2. Now pairs equals to, again we'll calculate the pairs when we'll visit 2, the child 2. Now our child is 2. So pairs equals to pairs. Initially our pairs are 3 plus. Now our size is, what is our size? Size is 1 again. Subtree of child. So 1 into what is n? 5 minus visited node. Visited number of visited node is 2 minus size. So 3 plus 1 into 5 minus 3 equals to 3 plus 2 which is 5. So total 5 pairs will be there now. So disconnected of node plus equals to pairs. So now we'll add 5, well, total 2 in this, so it will be 5 now. Got this? Now our child is 3. Child is 3 and visited nodes will be plus equals to size. So total 3 visited nodes have been done. Now again size equal to subtree of child. Size is again 1. Let's calculate it again. Total pairs is 5. 5 plus size. Size is 1 into what is n? N is visit nodes minus visited nodes is 3 minus size which is 1. So 5 plus 1 into what is 5 minus 4? 1. So 5 plus 1, total 6. Total 6 pairs will be coming here. 6 pairs at 1. Okay. And visited nodes plus equals to pairs plus equals to size. So total visited nodes will be 4. Now when child will be 4? When your child will be 4. Again size will be 1. Now again let's calculate the pairs. 6 plus your size into what is n? 5 minus visited node is 5 minus your size 1. 6 plus 1 into 5 minus 5 0. So total 6 only. So it will not update, it will remain 6 only and disconnected nodes will be pairs. At last we'll calculate, here we'll calculate if disconnected pairs of node, disconnected node of pairs, disconnected node of pairs is greater than disconnected node of max node. So max node equals to node. So now our max node will be updated to 1. At last we'll return disconnected node of 1 which will be returning a 6. Okay, this question is a bit lengthy. Please see again this video again. Please understand this explanation again, so we'll be able to grasp this problem more clearly. Got it? Now let's move to the next problem. The last problem of this contest, longest subarray with average at most k. So you are given, okay, let me show the code of the previous problem also. Yes. So initially, firstly make the graph, make this undirected graph. Now subtree array filled with -1 and then call the DFS. I hope this DFS was very much clear. Firstly, subtrees of size of node equals to 1. Now we'll iterate in the child. And after coming back to the parent, we'll do subtree size of node plus equal to subtree size of child, which will give us how many pairs are there for the particular parent. After that, After that, we'll make a max node equals to -1 and a disconnected pairs of node. Now start iterating the nodes. Pairs equals to 0. Visited node is 1. Every time you visit a node, visited node is 1. That means you have visited that node only. Now start iterating the childs. Firstly, size will be given from the subtree array. If your subtree child is greater than subtree size of node, that means the child has more number of pairs subtrees than the parent. Then directly increase your change your size with n minus subtree size of node. Now count the pairs. This is the formula. Count the pairs. Pairs plus equals to pairs equals to pairs plus size into n minus visited nodes minus size, and visit nodes plus equals to size. That means how many nodes have been visited from that particular node. At last, update your max node. Update your max node, and last return disconnected pairs of max node, which will give you the maximum answer. Okay, I hope the code is also clear. So let's move to the next problem. Next and the final problem. The longest subarray with average at most k. Let's read this problem first. You are given an array of integers. You are given an array of integers. An integer k. Our task is to find the length of longest subarray having average of elements at most k. So in this, the subarray with average at most k can be, let's find out, +1, 0, 6, 0, 1, 2, 3, 4, 5. At most k, let's say 2 plus 1 plus 3. 3 plus 1, 6, total 6 upon 5, which will give you 1. So it is at most k, like equal to or less than k. So 213 can be your subarray. Let's calculate for 2135. 38 and 311. No, 3. Okay, it will divide by 3. So it is 2. Yes, less than or equal to k. So divide by 4. So 11. 11 by 4. 4. It will be somewhere around 2 point any value. So it is not at most k. It is somewhere greater than k. Okay, so I hope you understood this problem. But how can we find this in a single in one go? In a single go, how can we find this problem? We know that average of a number, average of an array, sorry, average of numbers is equals to sum of all elements upon total number of elements. Total number of elements given, right? So our let's say x1 plus x2 plus x3 up to xn upon n. This is the average. It should be less than equals to k. It is given in the problem. The average, this is your average. It should be less than equals to k. Now let's make the equation x1 plus x2 plus x3 xn should be less than equals to nk. Basic algebra, right? Now let's try to do something from LHS and RHS as well. Like subtract nk from both sides. It will be nk minus x1 plus x2 plus x3 plus xn should be greater than equals to 0. Whenever you are doing any operation on LHS and RHS both, then this sign changes. this sign changes. Got it? So this is the critical step which helps us to make this problem easier. Now we have n k's here, right? We have n k's. What is n? N is the total number of elements. Total number of elements. So can I write this nk as k minus x1 plus k minus x2 plus k minus x3? Can I write this plus k minus xn? Don't worry, I will break down this equation again. Can I write this equation? Yes or no? Okay, let's say if I again break down this equation, so I will have k plus k plus k until n minus, if I take minus common, x1 plus x2 plus x3 plus xn. What is this? Kn. K is coming n times, so I can write this as nk. Nk minus x1 plus x2 plus x3 plus xn greater than equals to 0. Are these equations equal again? I have boiled down this equation to the previous equation again. So I think so we are guaranteed that we have written this correct. Okay. So this thing gives us some idea. This thing gives us some idea that we can try reducing the k from each and every element of the array. Let's what 4, 2, 1, 3, 5, 4, 2, 1, 3, and 5. And we are given, so let's reduce k from each and every element. K was 2. So 2 minus 4 is minus 2. 2 minus 2 is 0. 2 minus 1 is 1. 2 minus 3 is minus 1. And 2 minus 5 is minus 3. Okay. So our array has been converted to this. We have seen our equation, right? We will do k minus x1. We'll do k minus x2. We'll do k minus x3. Yes. So now our problem has come down to another problem, that is finding length of maximum subarray sum max subarray sum with sum greater than minus 1. Greater than minus 1. After doing this operation, our problem boils down to this problem: finding the length of max subarray sum with sum greater than minus 1. Okay. So if subarray sum we have to find, then firstly we'll try to compute the prefix sum of this array. Okay. So prefix sum will be firstly minus 2, minus 2, minus 1, minus 1 minus minus 2, and minus 5. This is the prefix sum of our array. Now we want to find the length of maximum subarray with sum greater than minus 1. So how I can find that? Yes, for each index we will find this only. What if I sort this array? If I sort this array, I will get the minimum index where I can get the value which is greater than my value, right? Greater than minus 1. If I sort this array, minus 5, minus 2, minus 2, minus 2, and minus 1. If I sort this array, I can get the minimum index which is greater than equals to -1. Don't worry, when we'll solve the when we'll do dry run, it will be more clear. Okay. So till this point we have made the prefix sum. So let's make the prefix sum array again. 1, 2, 3, 0, 1, 2, 3, and 4. 0, 1, 2, 3, and 4. So we'll make the array, prefix sum array of type pair. We'll make a pair of prefix sum -2, 0, -2, 1, -1, 2, -2, -2, -2 plus 1 is -1. Yes. And 2. -2 and -1 is, sorry, let's make the prefix sum again. Let's make the prefix sum again. -2, -2 plus 0, -2, -1, -1, -2, and it will be -5. 0, 1, 2, 3, 4. So we'll make the array of size prefix sum of type pairs. We'll store the pairs in our prefix sum, like -2, 0, -2, 1, -1, 2, -2, 3, and -5, 4. We'll store the index along with the prefix sum. And now we'll sort this array. While we sort this array, so that we can get the minimum index out of which we are getting a value greater than -1. 0, 1, 2, 3, 4. If I sort this array based on my sum, so it will be -5, 4. Then it will be -2, 0. It will be -2, 1. Then it will be -2, 3. And at last it will be -1, 2. Okay, 0, 1, 2, 3, and 4. This is our array, prefix sum array. After this, we'll make a minimum index array also, so that we'll start storing the minimum index in that, and we'll return that. As a minimum index will return, then we can find where we are getting the length. Okay, we'll determine the length from the minimum index. Okay. So minimum index 0, 1, 2, 3, 4, 0, 1, 2, 3, and 4. So currently our minimum index is 4 here. Now when we'll compare this with this, so it will be 0. Now compare 1 with 0, 0. Initially again 0, and then 0 only. This is our minimum index. Now we'll start iterating the minimum index and add the array again. Our array was -2, 0, 1, -1, and -3. 0, 1, 2, 3, and 4. So again sum is 0. Now we'll do firstly sum equals to sum plus array of I. Currently our prefix sum is -2. We'll check if our sum is, our k was 2 na? If our sum is greater than k, no, it is not greater than k, then we'll find the index where we get the minimum index which is greater than our current sum. Okay, we'll find the minimum index where the value is greater than our current sum. And since the array is sorted, we'll do a binary search here. We'll do a left and right. First we find the mid. Mid is 0 plus 4 by 2, which is 2. Check if the value if the value is less than if the value is less than my well. What first? Is it less than equals to my sum? Yes, it is equal. So initialize your answer with mid. Okay, and do low equals to mid plus 1. Now again check 4 plus 3 by 2, 2, 3. Check if this value is less than our sum or not. Less than or equal to our sum or not. Yes, it is equal. So make your answer with 3 and do low equals to mid plus 1. So low will be here now. Again find out the mid. It will be 4. Check if it is less than equals to your well. No, it is not equal. So do right equals to mid minus 1. So initially your answer is 3. That means till this point you have a value, you have all the values which are less than your sum. Okay, so you will update your result also. Update your result also with your current I was 0 here, with I minus your minimum index of index. Your index you got was 3. Okay, what is I? I is 0. 0 minus what is minimum index of 3? 0. So initially your answer is 0. Let's go again. Let's see what's the next answer possible. Let's say our I is now on 1. Okay, and your prefix sum has become now minus 2. Now the same answer 3 only will get, and will update the result with I minus minimum index of this 3. So it will be 0. So answer will be 1 now. Now when your I will move again, your sum will update with minus 1. Again do binary search for minus 1. Your left will come here and your right will come here. Make a mid 0 plus 4 by 2. Check if the value is less than your value. No, it is not. Check this sum will send in the function for binary search. Check if your current value, if your current value is less than your val or not. Yes, minus 2 is less. Minus 2 is less than equals to minus 1. So we'll do low equals to mid plus 1. Again check. Again we'll find the mid. 4 plus 3 7 by 2, which is 3. Check if it is less than your minus 1 or not. Yes, it is equal. So do low equals to mid plus 1. Again do 4 equals to 4, mid equals to 4 plus 4 by 2, which will come your mid only. Check if the value is less than equals to your sum or not. Yes, it is equal. So answer will update by 4. Now how will calculate the result? Max of 1 comma max of 1 comma your I was here 2 minus minimum index of your 4, which is 0 only. So this is your answer now. Max of 1 comma 2, your answer is 2. Got it? Now when your I will come here, again your sum will be updated into minus 2. For minus 2 you are going to get the answer as 3. Okay, we have calculated previously also that for sum equals to minus 2 we are going to get the index 3. So we'll do 3 minus 0, the index. Okay, I minus minimum index of id. This id we are getting from binary search. So what is I? 3 minus minimum index of this id 3 is 0. So currently our sum is 3. We'll update the max. Now when your I will come here, your sum will be minus 2 only and minus 4. Sorry, your sum will be equals to now -5. Okay, now let's calculate for -5. Firstly calculate the mid. 0 plus 4 by 2, which is 2. Mid will come here. Check if this value is less than your sum. No, it is not equal. -2 is not less than -5. So what we'll do? Right equals to mid -1. Again do 0 plus 1 by 2, which is 0. Check if your value is less than equals to your sum or not. -5 is less than equals to -5. Yes, it is equal. So answer equals to 0 and low equals to mid plus 1. Again check 1 plus 1 by 2, which will come 2. Your current sum will be -2, which is not equals to, which is not less than equals to your sum. So we'll not update the answer. We'll directly return 0 in this case. We'll directly return 0 in this case, and what we'll do? I minus 4 minus 4 minus minimum index of 0, which is 4. So you are going to get 0 in this answer, but our max answer is 3. So we'll return 3 in this case. Okay, so this was all the dry run. Let's see the code as well. So this was the first thing which we did. First thing that was, we subtracted k from each and every element, and at last we find the largest subarray which has the value greater than -1. After that, firstly we'll make up pairs of prefix sum and our sum also. Now we have initialized the sum. Now we'll start iterating in the array also. We'll do sum equals to sum plus array and prefix sum equals to, we'll push back in the array as a sum. Sorry. Now we'll firstly sort the array and then we'll make a minimum index. After that, we'll firstly store the minimum index as minimum prefix sum of 0 dot second. Okay. Here we stored minimum index as prefix sum of second. 4. Prefix sum of second. After that, we are sorted. Now for int I equals to 1, I less than n. Since we have already computed our 0th index, now we'll compute from the first index and make the minimum index. After that, we'll again initialize 0 and start sending the sum in our binary search. Here, this is our binary search function, in which we'll calculate whether the prefix sum of first is less than equals to our val or not. Whatever sum we are calculating, we'll send it in the binary search and check if our minimum index of index is less than I, then we'll do I minus minimum index of index. Okay, and at last return the result. This result we are going to return as the largest subarray which has sum greater than -1. Okay, so our code firstly goes to here, and then this function starts, which will call a binary search function and return a particular index. Okay, so this problem was mix of pre-computation, prefix sum plus binary search. Okay, so this was all about our post analysis. Please see this code, try and for some more examples from your end, and you will be able to understand the problem. Hope we'll meet in the next session. Till then, all the best. Keep practicing. Thank you.